Hello and welcome to this Bio43 pre-lab video. Today we're going to talk about bar graphs. Bar graphs are the way to communicate results in a scenario where we have a categorical independent variable and a continuous dependent variable. Let's ground this tutorial in a sample situation and review how to construct testable hypotheses and predictions as we go. Suppose we want to know if there's a difference in the size of the tetrahymena living in nature and the tetrahymena we use in the lab. Our null hypothesis is the source of tetrahymena has no effect on its size. A simple alternative hypothesis would be the source of tetrahymena affects its size. A better alternative hypothesis could be because growth media has a higher concentration of nutrients than lake water, lab-grown tetrahymena are larger than tetrahymena found in nature. This doesn't just suggest an effect exists, it hypothesizes a direction for the effect, which condition will have the larger size, and provides a mechanism for the effect. Based on this hypothesis, we can design an experiment where we collect some tetrahymena from fake lake and some from the lab. We use a microscope to look at 10 organisms from each condition and measure their lengths. We predict the length of tetrahymena from the lab stocks will be greater than the length of tetrahymena from fake lake. This is similar to the hypothesis, but note that it is in future tense and has specific details based on this experiment, while the hypothesis is a more general present tense statement of presumed fact. Now we collect the data, which I've put in this Excel document. Again, I'm using the Windows desktop app here. The Mac version will be similar, with a few things moved around. Don't use the online version since it lacks some features entirely. We want to check over the data, make sure it's in a format that will be easy to work with, no missing values or anything weird. This 500 is a bit odd. Double check my notebook, and indeed that should be 50.0. Correct that transcription error. Now we want to get our summary statistics. For continuous dependent variables, like length, this would be the means, 95% confidence intervals, and n values. So we'll type in those equations, which you should have seen in the previous video. The means and 95% confidence intervals can be much more effectively communicated visually. We'll make a bar graph where the means are the heights of the bars and the 95% confidence intervals are the error bars. A bar graph like this is a typical plot to use when dealing with a continuous dependent variable, again that's the length of the tetrahymena, and a categorical independent variable, their source. There are many ways to set up the graph. I'll just show you one way. First, click away from the data, go to Insert here and choose a normal 2D bar graph. This just brings up an empty box at first. Click on it, then click Select Data up here. Now we add the relevant data. You can ignore the series name and just go to series values. The heights of the bars should be the means, so those are the values we'll highlight here. This makes the bars appear, though they're just labeled as 1 and 2. We can fix this by editing the horizontal axis labels. We'll just select the column titles. You may want to use more descriptive titles, but this will work for now. Click OK. So there are still a few things off here. We can fix most of them by editing chart elements. Click on the plus sign here. We can add axis titles, get rid of chart titles. Figure titles should be part of the caption that you'll later put below the figure when you make your report. I usually like to get rid of grid lines, but that's more of a personal aesthetic choice. The really important thing we're missing here is error bars. Clicking the box adds some random default error bars, but we want the error bars to be our 95% confidence intervals. For that, we need to go to More Options and pick Custom Values. Make sure to specify both the positive and negative error values as the 95% confidence intervals. Now let's add in the right axis labels with units if appropriate. And at this point, we're pretty much done, but there are some more aesthetic choices we can make. You can click on the bars and play around with the color and spacing. Make the error bars a little easier to see. For some reason, there is no y-axis by default, so I like to add that in. Make the other axis match that. Make sure the font is large enough. Just make it so that it looks nice to you. Add a caption, and this is ready to go in a report. But we still have some more analysis to do. Yes, the lab-grown tetrahymena are larger than the ones from the lake, but is that difference statistically significant? Well, performing statistical tests is a big topic that really deserves its own video, so let's come back to that next week. You should now have a better understanding of how to make bar graphs. We'll talk about other ways to use graphs to communicate data as the semester goes on. And hopefully, you're starting to think more about how you'll construct your own hypotheses soon. See you next time.